So how can we find the period? So we know it's up at 5, so it's not C or D. The period is 2 pi over b. And what's the b? The formulas are a cosine bx or a sine bx. B is the number next to x. So to find that, we got to have the period. What's the period? So remember again, what does sine and cosine do? Sine starts at 0, goes high, goes low, back to 0. That's one cycle for sine. Cosine, put them down here, which is what we're dealing with, starts high, goes low, comes back high like that. That's one period. This from one period, one cycle, from there to there for cosine. That's one period. So the question is, what portion? So you got to be pretty tricky here. From there to there. How about just there to there? That's what portion of a whole cycle, of a whole period? A quarter. Do y'all see that? That's a fourth. Why? Look over here. It's this part, isn't it? Just like one section, and then to the middle here would be 2, and then to right here would be 3 sections, 4. So this, meaning that, is 1/4 of a period, of a whole cycle. It's 1/4 of a whole cycle, isn't it? You see the trick there? You have to look and go, well, they've given me 1/4 of a whole cycle. When it hits 0, when it goes from high to 0, right? Because it goes from high to 0 to low, back to 0, back to high. So when it goes from high to 0, that's 1/4 of its cycle, isn't it? Did y'all see that? So if I find out how far this is and multiply by 4, I'll get the whole period. And then I can plug the period in here and solve for b. Pretty tricky one. Does everybody see that? Everybody see the game plan? What I'm saying? I'm saying that when the cosine function goes from high to 0, that's 1/4 of its cycle. Then it goes low, that's the next quarter. Then it goes back to 0, the third quarter, and back to high, that's the fourth quarter of its 4 parts in one cycle. So this is 1/4 of a whole cycle for cosine. Where does that hit? Okay, so that's 1/4. We got to find out wherever that hits. Wherever that hits right here. And then multiply it by 4, and we'll have the whole period. It's a pretty advanced one, isn't it? So, well, where's it hitting? Can you tell? Where's that hit exactly? Yeah, exactly. Did y'all see that? See how this is pi, 1 pi, and this is 2 pi, and that's right in the middle of 1 and 2. What's right in the middle of 1 and 2? 1.5. Isn't that 1.5 pi? Right there in the middle of 1 pi and 2 pi? 1.5. Can you change that to a mixed number? Yeah, you multiply the bottom, add the top. 1 times 2 is 2, add 1 is 3/2 pi, huh? That's 3/2 pi. You tracking with me? So right here is 3/2 pi, and it's 1/4 of the way through a full cycle. So take the 3/2 pi, 3/2 pi, and what am I going to multiply by? Times 4 to make a whole period, because that's 1/4 of the period, 1/4 of the cycle. So the period will equal the 3/2 pi times 4, which is what? 3/2 pi times 4. 2 goes into 4. 2 times 6 pi. So the cycle, the period for that cosine function must be 6 pi. Now, I can use this formula and solve for b. You tracking with all these intricacies? This is pretty tricky. Everybody see that? So I found this right between 1 pi and 2 pi. So it's 1.5 pi. Change it to a mixed number, 3/2 pi. And that's 1/4 of a whole cycle. So take that 3/2 pi and multiply by 4. When you know, maybe I did that in a weird way for you. If you take 3/2 pi times 4 over 1, that's 12 pi over 2, 6 pi. Like that better? 6 pi. So 6 pi is what? Is the period. The whole period must be 6 pi. It starts at 0. It must end way over here at 6 pi. You know, if you did the whole thing, it must end at 6 pi for one period. Okay, so what? Well, now, let me get a fresh screen here. Now 6 pi, so now I know the period. The period is 6 pi. So I can use the formula. What formula? Period equals 2 pi over b. That's what you want to have in your 3x5, your full sheet of notes, for sure. Plug in the period. So 6 pi is 2 pi over b. Right? Period's 2 pi. How can we solve that for b? Put this over 1. Diagonal, diagonal. 6 pi times b is 1 times 2 pi. Like that. And last step to get b alone. Divide by the 6 pi. B is, pi's cancel 2/6. 1/3. It is answer A. 1/3. The B, the thing next to X, is 1/3. How are we doing? You guys look a little overwhelmed by that one.
Yeah.
I was overwhelmed about half the time in math and science classes. I'd be kind of very confused, but I would go home and re-look at it. That's what you need to do. Yeah?
I was wondering, how do you know there's no vertical shift on that? You assume that it's just a quarter of it. Because if it was a vertical shift, couldn't that go further down?
Right. There could be. You're right. It just doesn't look like it. I guess is in the emotion. See, it looks like this is about to go like that, which would be at -5 and +5, so it's centered at 0. It just looks like it's not. At some point, we've got to assume, that it's not. There's no vertical shift there. See how it just looks like it's about to pan out at the -5 there? And since it pans at -5, then 0's in the middle. Going from -5 to +5. All right. So, other questions on that one? Does that make sense how we went through that? Well, I better move on. We took like half an hour on that to be able to know the sine and the cosine that well. Try this one. See if you can figure out which one of those is right. Is that one a sine or a cosine? How do you know it's sine? Starts at 0. It's good to do one cycle. Because they're giving us more than one whole cycle. So make sure you put a dot where the cycle ends so you have a good view on what is one cycle. And then use the same formula we just used. Period equals 2 pi over b. 2 pi over b. Where we're looking for the formula a sine bx. B is the number next to x, huh? Period's 2 pi over b. So one cycle ends here, doesn't it? Does that make sense? Because sine goes low, high, back to... That's one cycle right there. One period. Everybody tracking with me? The rest is going into the second cycle, second period. Good there. All right, so what is this point there?
6 pi.
6 pi, huh? Right, because this is 9 pi here. If you just count the marks, they're each a pi, aren't they? Tracking with me? Is that too quick? Right, if you count the marks, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 to get out to 9 pi. So each mark must be a pi, huh? So this is 6 pi. So from there to there goes from 0 to 6 pi. So the period must be 6 pi. See how we came up with that? A little easier than the last one, huh? All right. And that's actually solving the same equation we saw last time. Guess what b is going to be? Same thing it was a minute ago. 1/3. All right, let's solve for b. Put this over 1, diagonal, diagonal. 6 pi times b is 1 times 2 pi. So 6 pi times b is 2 pi. How do we solve for b? Divide by 6 pi. b is 1/3. So it's minus 5. Oh, it's minus 5 also because it goes down first, huh? It goes down first instead of up. Minus 5 sine 1/3 x. There it is. It's not e. It's there.
Yeah.
There'll be a few. I obviously I didn't even know in the last one. I would have told you 4. That would have made it really scary, huh?
You know, it could have been, but then, like, you imagine what you've done if you said 9.
Yeah. Questions on that one? We good? All right, so we have 3 tan inverse 2x is pi. All right, what should we do to solve for x there? Give you just a second. So these are all new ones. These are all ones off. This would be off 7-1. So those last two were off 6-4. These two would be from 7-1. Yeah, let's start by dividing by 3, huh? Let's start by dividing by 3. Good idea. Okay. What do we do now? How are we going to solve? How are we going to solve for that x? Could we divide both sides by the tan inverse? Why not? What's that? Because it's a toaster. Good. I hope that's making some sense. That's not multiplication. That does not mean tangent inverse times 2x, does it? It means tangent inverse of 2x. That 2x is plugged in. It's not multiplication, is it? You guys getting that? Especially if you're going to calculus, that's a real issue. That's not multiplication. It's plugged in, so you can't divide. You can't divide. You've got to take tangent of both sides, right? Because these will cancel each other out. Because it's the opposite of tangent inverse. That's how we get rid of a function that's outside of something, is we do the opposite function. Like that. That makes sense? That's why we have inverse functions. So then those cancel, and we just have 2x. The other side, tangent pi over 3. Good to there? See how that got rid? That's what gets rid. That's how you get a function off of something. When you have like an x plugged in to a function, that could be logs, plugged into a log, plugged into an exponential, plugged into sine, cosine, tangent, tangent inverse, whatever, any function. You do the opposite function to the front, the inverse function, to both sides. Okay, now, how do we find tangent of pi over 3? So, yes, good. Yeah, cosine is always first, sine is always second. Really important to keep that straight. I was doing one of these the other day, and I reversed it. So watch out. Yeah, cosine comes first, then sine. So tangent of pi over 3 is sine over cosine, root 3 over 2 over a half. Flip up that half, and then cancel the 2. So tangent of pi over 3 is root 3. Bring it back. Tangent of pi over 3 is root 3, and then divide both sides by the 2. And we've got our x. Is that good? Everybody see here how the regular function canceled the inverse? Right? All right. Let's keep going. So to number 4. Okay, so cosine inverse of negative root 2 over 2. So how do we find the cosine inverse of negative root 2 over 2? So it's cosine inverse, right? Yeah.
Couldn't you turn root 2 over 2 into like a 3?
Good question, good question. Yeah, tell me, guys, is that right there, that negative root 2 over 2, is that an angle or an answer? Yeah, it's not an angle. It's not degrees nor radians. It's not an angle. Are we clear on that? You remember that? Remember, like cosine or sine or whatever, the normal cosine, you put in angles, you get out answers for normal cosine. For cosine inverse, you put in answers. What you get out is angles, huh? Remember that? Remember reverse? That's what all inverse functions do, is they reverse inputs and outputs. So you put in an answer, you get out an angle. So that minus root 2 over 2, that's actually an answer. It's not an angle. It's not degrees. It's not radians. It's not an angle at all. It's not an amount of opening. It's an answer. And I'm looking for the angle that goes with that answer. So I go to the unit circle, and I look for the angle that goes with that answer for cosine. Make sense? So let's go to the unit circle. I'm looking, where is cosine come out to have this answer? So here we go. Here's the unit circle. Let me get rid of all this stuff. Look at it for a minute. Where do you see cosine is negative root 2 over 2? Yeah, the cosine is going to be, yeah, there's cosine right there. Here's cosine positive root 2 over 2. Here's cosine negative root 2 over 2. Here's cosine. Right, cosine's always the first one, huh? So there's the 4 places where cosine has some kind of root 2 over 2 thing. This one's positive, so no way. This one's negative, and this one's negative, root 2 over 2. So it's either this one or it's that one.
Does it matter that it said it was the inverse cosine?
Oh, right, that's why we're looking for the answer, not the angle.
But that's why we look for the answer. It wouldn't be switched because it was the inverse. It's going to be that particular one when we look at it.
Yeah, so when I see
I'm asking though, like because it's the inverse, I'm thinking I need to flip something before I look at the unit circle.
Oh, no.
Just go straight to that.
Right, yeah, no flipping anything. Yeah, cosine inverse just means that these guys have inverted, not that we flip anything. It just means the inputs and outputs have switched. Yeah, good question. That's what an inverse function does. Yeah, it's not like a reciprocal function,
right,
which is a turn up like sine with cosecant or something. Yeah, it's not that. Good question. It's inputs, outputs. That means I'm looking for this answer. And so when I see that answer right here and right here, right, there's cosine answer, they're both negative root 2 over 2. So which one is it, the 135, or I guess they want radians, 3 pi over 4 or 5 pi over 4? Which one is it? Good. Right. Remember the whole talk we had? Maybe not so much. about what restricted quadrants. Remember, these 2 quadrants are the only 2 you ever look in for sine inverse and tangent inverse. Those 2. And these 2 quadrants are the only 2 you ever look in for cosine inverse. Remember that? That's an important fact for inverse trig function looking. Right? You really got to know that. That's the restrictions on the inverse trig functions. So notice they both share they all 3 share quadrant 1. See how they overlap in quadrant 1? But then, so cosine inverse is the top 2 quadrants. Sine and tangent inverse only use the right 2 quadrants. So I don't have time to redo that whole speech, but if you missed it, you might want to look back to section 7.1 and watch that lecture where we talked all about that. That's an important piece of information. So, therefore, I just take the 3 pi over 4 answer. That makes sense? Don't take the other one? I guess you don't need to look back. As long as you know that, that's all you really need in the end, is only use those 2 quadrants for cosine inverse. Only use the right 2 quadrants for sine inverse, tangent inverse. All right, 3 pi over 4 it is. So 3 pi over 4, boom. Good? Moving on? For you. So yeah, so here's part 2, number 24. Radio transmission tower is 210 feet tall. How long should a guy wire be? If it is to be attached 6 feet from the top and to make an angle of 23 degrees with the ground, give your answer to the nearest tenth of a foot. All right. So a picture would be helpful, I think. So it's kind of like this. It's like we've got a radio, we got this tower, got this radio tower thing, and we're attaching a guy wire to the ground. This is the wire. It's a right angle, assuming that the tower goes straight up, not the leaning tower. Goes straight up. We got a guy wire. The tower goes up to 210 feet, but we're attaching it at, what, 6 feet below that? So 204. And the angle's 23 degrees with the ground. Let me hold up there for a minute. Is that making sense what I'm doing? So we got this radio tower that goes all the way up to 210 feet, but we're attaching the wire 6 feet from the top, so at 204 feet. 6 feet below the top. We attach the wire, goes all the way to the ground, makes the angle 23 degrees with the ground. This is the ground here. Right there. So, and the question is, how long is that wire? So if you see a radio tower, you know the wire's up at 204 feet, goes all the way down to 23 degrees with the ground. That angle, the wire makes a 23-degree angle with the ground. How do you find the length of this wire here? What should we do?
Find the other angle.
We want to talk about SOHCAHTOA, huh? SOHCAHTOA. So we have this angle. This over here is 204, right? From there to there is 204. To the top of the triangle. I don't need the 210, just to where the wire hits at 204. So what this angle, this side, and then that's the side I want. So I want the hypotenuse. This is the adjacent. The ground is adjacent to the angle. This 204 is opposite from the angle, huh? So what trig relationship involves an angle, an opposite, and hypotenuse? Sine. Sine is opposite over hypotenuse, huh? So the sine of 23 degrees is 204 over hypotenuse, or C, or whatever you want to call that, the wire. Everybody see that? Opposite over hypotenuse. All right, and so now we just solve that equation. How do I solve that equation for H? Yeah, put it over 1, diagonal, so we get H sine 23 equals 1 times 204, like that. Right, it's diagonal. Last step is divide by the sine 23. Boom. H equals, hit the buttons on your calculator. And I'm getting, we got to make sure in degree mode. Yeah, I am. So I got 522. 522.09.1 it'll round to. And so it's A. You know, funny thing happened, it's like, it might be 6-7 years ago now. I was teaching summer school. Just reminds me of coming up on summer school. And this problem. I was teaching summer school. I got back to my office one day, and I had a phone message. I listened to the phone message, and this person said, hey, Brett, I'm out here on this is Hank, or something. I don't remember what it is. This is Hank, or I'm out here on this job site, and I'm looking at this, there's this big tree, and we got to take down this tree, and I can't tell if I need to order the medium backhoe or the large one, because I can't tell if the tree is closer to 100 feet or 150. I'm using one of those, it's called a sextant, where you do the angle, you can see the angle of elevation, same kind of thing. Said it's like a 23-degree angle when I'm about 200 yards from the tree to the top. So can you tell me how tall that tree is? Here's my number. Thanks. So I played that message and I went, hey. Yeah, use my first name, Brett, like he knows me. And I'm like, hey, Hank. Who do I know that's Hank? I just kept thinking. I couldn't come up with it. So I finally called the number back, got on the phone, and I'm like, yeah, this is Brett Aaron, Fresno City College. And he's like, oh, yeah. So I got this tree. He just goes right into it again. I'm like, well, hold on just a second, Hank, just a second. I said, I'm sorry. I just don't remember where I know you from. He's like, oh, you don't know me. I just called up the junior college because I had a math problem I needed to solve. So I just called up the community college. They put me through to a math teacher. And I'm like, oh, Okay. And then I solved the problem and gave him the answer. I guess we're here to serve the community, so. There it was. It's kind of funny. He was so casual about it all. What's that?
Like that actually happened?
Yeah, I don't think it was a gag. He seemed very sincere. Rudy.
There was a problem like this, very similar to one of this one's on, I think, 8.1.
Yeah.
Where it gave you like an angle and a sine angle for the side. And when I did it, I had to like subtract 90 from like whatever angle it was given, like 90.
Did you find the other angle?
Yeah. So I was wondering, when would we use that? Like, why didn't we subtract 90?
Yeah, I'd have to see the problem. Do you remember what number it is?
Honestly, the only way you would have to do it is if they were asking for a different thing. You know what I mean? Like, otherwise you don't need to. Like, if you can, you're given what you're given, you can plug it in.
In this case, it wouldn't matter. Could you find the problem, Rudy? I could look at it if you. Let me know if you get it, and I've got a couple that I think would be helpful to look at.
Yeah.
But you let me know if is there any that you really want to see that you like worked on and you really want to see them, and I can write them. Well, let me know. Let me know if there are. I think this would be really important for us to do the absolute value. It's been a long, long time since we've done. I want to do some exam 1 stuff. It's been the longest, at least the harder ones. So I want to do some absolute value. I also want to do the greater than, less than. Those are pretty tricky. And maybe a couple word problems. But you let me know if there's something in particular. We've got 55 minutes to do what we can. But again, all this stuff is out there already. So I'll just do what I can to make this time beneficial for you. But all these should be out there on YouTube already, right? Like if you wanted to see this one, where would you go? How do we solve... Do you remember anything about greater than, less... about absolute value? Let me write again the instructions. So absolute value... First, get alone. So like what I mean is like on number 27, when we do that one in a second, we're going to have to subtract 9 from both sides first, huh? Because that one's not already alone. That's the first step. But anyway, after that comes the more normal stuff. There's 2 kinds. There's absolute value greater and there's absolute value less. Absolute value greater and absolute value less. And they're treated differently. Remember, one of them becomes 2 separate statements with an or. And the other one becomes a compound inequality, a triple with a thing in the middle. And you got to know which is which. Put that on your sheet for sure. So let me write it out for you. So for the greater case, and then over here I'll do the less case. Well, I'll do it in a second. So for the greater case, like if you have absolute value of some inside greater than a number. And it could be greater, it could be greater than equal. That part doesn't matter. But if it has a greater... or a greater than equal, same thing. Those are the kind where you got to break them in 2. You got to say inside number, no more absolute values. This is the removal step. Removal. I'm going to yank off the absolute value signs and say, okay, inside, you're less than or equal to the negative of the number, or, let me try that again there. The negative of the number, or inside, you're greater than or equal to the positive of the number. And then you just ... from there. And you end up with 2 answers, a negative infinity united and a positive infinity, some kind of numbers in those other spots. Do you remember that for the greater? And then for the less, absolute value with inside less than or equal to a number. Those are the kind you break into a triple. So you go negative number, less than or equal to inside, no more absolute values, less than or equal to positive number. You go through and solve, and you end up with just 1 parenthesis, not 2. So you remember those fundamental differences between those 2? So it makes a big, see how number 26 is a greater problem and 27 is a less. Probably you'll have 2 of those, at least 1 or 2 on the actual final. So greater has to be done one way, less has to be done the other. Greater, I think a memory device just to help you remember, greater always has a greater number of answers, 2 parentheses. Less has a less number of answers, only 1 parenthesis. So what that means is right away, if you just know that fact, you can eliminate some of the options right away, huh? You can come in here and say, look, it's a greater, it's absolute value greater, it's going to be greater number of answers. It's not C and it's not D. They only have one parenthesis, not two. It's either A or B, or could be E, of course. And then on 27, 27 is a less. So that's going to have less answers. It's not A. It's not D, huh? See how we can eliminate those? So if you just know that fact and have that on your sheet. And again, recognition is a lot of the battle on math or science final. How are you going to, what's special here? The absolute values. That's how you're going to recognize. There'll be one or two absolute value problems. So if you have this on your sheet, that'll help you. Okay. Also, I want to take this opportunity to kind of make it make sense for you. That's what happened for me a lot when I would take math classes and science. I would struggle through and sort of get things not really, and I'd kind of just imitate what the teacher did and monkey see, monkey do kind of, and not really get it, but just imitate. And then at the final, sometimes studying for the final and hearing it again, I would start to really get the reason why it made sense. And that's always best. If you can eventually get to where it's like, oh yeah, that makes sense. Because then it's really yours. You're an owner, not a renter at that point. It's yours for keeps because you really get it. Why is this true? Let me say it. Let me just spend 1 minute maybe saying, why is it true that the greater does the two things and the less does the one thing, and why? Why is that all logically true? Well, think with me for just a second. If you had something like absolute value of whatever, I'll put question mark, greater than or equal to 2. Versus over here, I'll put absolute value question mark less than or equal to 2. Just think with me about what that means. What could I put in those absolute value signs? What could that inside be? The absolute value of what? What if I said, hey, I'm thinking of a number, and the absolute value of it comes out greater than or equal to 2? What could be in there? Well, 2 or 3 or 4, and on you go to infinity, huh? Anything like that, the absolute value would be bigger than 2, right? Or negative 2, negative 3, negative 4, onward to negative infinity. Because if you put any of those in there, the absolute value of negative 2 or negative 3 or negative 4 would be positive, and thus would be bigger than or equal to 2, wouldn't it? That makes sense? That's just true, isn't it? You could put in there anything 2 or bigger, or anything negative 2 or smaller. See how it's to the right and to the left. See how to the left, to the right, right? Inside less than negative, that's left on the number line. Inside greater, that's to the right, isn't it? Whereas over here, now what could I put in here to make that one true? What could I absolute value what comes out less than 2, less than or equal? You could put in negative 2, negative 1, 0, 1, and 2, and that's all. Right? Do you see that? You couldn't put in negative 3 because the absolute value negative 3 would be positive 3. That wouldn't be less than 2. You couldn't put in positive 3, of course, either. Or anything bigger. Do you see how when you have absolute value less, it limits it to one section of numbers in the middle? One section of numbers in the middle for absolute value less? Does that make sense? A little more sense than I did before? But absolute value greater has two sections, negative stuff and positive stuff, doesn't it? That's why that's true. And if you just really feel that, you don't need to memorize any things or formula sheets. You just look at it and go, this is what it means. And you write it out. All right, so now that we know what it means, we got to actually solve it. So let's do that. So this is greater. And so for the absolute, so let me write it out, 5x plus 2 greater than 3. What do we do for, go back to greater. For greater, we make two statements, and it really matters which way those symbols are and all that little stuff. The first one is less than the negative, greater than the positive. So you remove it. Less than negative 3 or greater than positive 3. Do you see how we do that for greater? That's the removal stage. Notice I have yanked off. I've yanked off those absolute values, haven't I? It's the removal stage. It's the meaning of what those absolute values were saying. I yanked them off. That's the truth of what they're saying. Now we can solve. Subtract 2. 5x is less than negative 5 divided by 5. X is less than negative 1 here. Subtract 2. 5x is greater than 1 divided by 5. So less than negative 1, greater than 1/5. B, huh? Less than negative 1, greater than 1/5. Yeah?
Quick question. Would there be a difference if, like, say, like,
Bless you.
if like it said or if there was like a union symbol. Is there a difference?
Same thing. No, or is union. Or and union are the same. Either way is totally good.
I put union and I looked at
Yeah.
or I thought maybe it was different.
Yeah, totally same. Good question. Union and or, that's what it means. Good. Other questions on that one? How about here? Let me squeeze this in. Let me just do the other one right here next to it. Okay, so what do I do first on number 27? Subtract that 9. So absolute value of x plus 2 less than or equal to 4. And then I remove those absolute values. So which one? That's a less than. So remember, that's mean it's going to be between negative 4 and positive 4. Remember, that's a triple, what's called a compound inequality for the less, instead of two separate statements for greater. Greater is greater number, two separate statements. Less is just one like that. See that? Okay, so then how do we solve for x there? Subtract 2. All the way across, you do all three at the same time. Negative 6, x 2. Between negative 6 and 2, C. There it is. Good? Be able to get absolute values on the real exam? Questions on that one? All right, I'll move on if you're good. Rudy? All right, let's solve 36. This is a hard one. These things were hard and they're real different, so I wanted to review that with you. There we go. Okay, so there's a mark on this one that means something special. It's the greater than less than. So when you see greater, and there's no absolute values here, so I guess we saw it with absolute value, huh? So there's a special kind of problem. Two kinds, there's absolute values, we did that, and now this is greater than and less than. Do you remember with these kind, we got to eventually go to the number line, and we have the different sections, and we test if it's above or below, above or below, above or below. That's one of these. Remember that whole rigmarole? So let's go through. It's a big deal. It's a long thing. How are you going to remember? A lot of the battles, recognition. What's going to jump off the page on the final next Thursday? Greater than, less than. All the rest of the test is equals, except for the absolute value, greater than, less than, and then these. See how number 36 and 37 are both greater than, less than kind of questions? Okay. So how do you do that? So I'll put it over here. So greater than, less than with x squared or higher. What do? Step 1. Get a 0. Get a 0. X squared, I'll say or fraction. Because I'll give you the instructions for 36 and 37 at the same time. So if you have an x squared with greater than, less than with x squared or higher, like x cubed or x to the 4th or whatever, or you have a fraction, step 1 is get a 0 and make it into one fraction. So like on this one, I'm going to jump this over and then put those together as one fraction. That's what I'm saying. Step 2. Factor top and bottom. Step 3. Numerator equal to 0. Denominator equal to 0. Solve. And those are zeros. Solve denominator equal to 0. What happens when the denominator is 0? Those are undefined, so they are on the graph vertical asymptote points. Remember that? Remember whenever the denominator is 0, those are vertical asymptotes? Because it is undefined. You can't touch it. That's why you can never touch a vertical asymptote, because it's undefined there. Denominator 0. Okay, so there's the plan, and then, well, that's step 3. And then step 4, I'm kind of out of room here. Step 4 is you'll have like a number line, you'll have boom, you'll have like boom and boom. And then you test each section for positive or negative. Use the last step would be easiest. Use the last step to test. Okay. So there's the instructions for how you solve greater than, less than. Put that on your sheet of notes. Okay. So and why am I so I want to know, like, is the graph where is it? Is the graph like below here and above there and below here and above there, or what is the graph? Where is it above and where is it below? Where is it positive and where is it negative? Because positive means greater than 0, doesn't it? And negative means less than 0. So, in other words, in this section it's positive, in this section it's negative, in this section it's negative, in this section it's positive, huh? See what I'm saying? That's basically the answer to 37, if you want to know. This is 1, this is 6, this is negative 29, I think. That's how the graph goes. I just did it last hour. That's how I know, I remember. And it took forever, so I don't want to redo it. You can find it in the old notes, you know, the old practice exam. But there's basically the answer to 27, I'm telling you ahead of time. It comes out like that. But anyway, let's just do 36. So now, how do you know what you want in the end? Do you want the places greater than 0 or less than 0, positive or negative? Well, they're telling us on this problem, at least on 36, they want greater than 0. What does greater than 0 mean? Positive areas, huh? They want us to find the positive areas. So let's do that. Let's factor. How do you factor this thing? That's my first step. Get a 0. We already had a 0. Make it one fraction. I don't have fractions right now. Factor the top and the bottom. I don't have a bottom. Just factor that thing. Good. First step is GCF. Remember that? Just do one big parenthesis. Take out the x. X squared minus 4x. Remember with GCF you do one big parenthesis. Then the next step you'll do the 2, huh? So what's that going to be? Yeah, what multiplies to be 45? Has been, yeah, 5 times 9. How do you get minus 4 in the middle? Negative 9, positive 5. That good? So you factor top and bottom. Well, there's no bottom here. Just factor that. And then you set it equal to 0. Numerator, but we don't even have a denominator. Just set each part there equal to 0. So that means x alone is 0. Or x plus 5 is 0, or x minus 9 is 0. So this one's done. This one, move over the 5. This one, move over the 9. And we've got our 3 answers. Well, we're not done yet, but we got the 3 places we're going to put on the number line, and we're going to test the 4 sections in between them and outside of them. Is long. And our screen is flashing. We good there so far? Everybody see what I'm doing? So this is what you got to remember for the greater than, less than ones. You got to get a 0, factor, set each part equal to 0, and then go to the number line. So I'm going to take those 3 to the number line now. 0, negative 5, and positive 9. Let's do that. So to the number line we go. And what was it again? Negative 5 is the left, 0 and 9. Okay, so negative 5, 0, and 9. That good? So those are the 3 places on the number line. Those are my 3 answers: 0, negative 5, and 9. Put those on the number line. And let me bring forward this last step I had. X plus 5, x minus 9. So I'm going to, let me write over here, x plus 5, x minus 9 greater than 0. So I'm going to plug into that. Well, yeah, you could. Or you could do the in behavior, bounce, pass through, all that kind of stuff if you wanted. Do you remember any of that kind of stuff? Sort of? There's a lot to remember, isn't there? So either way, if you prefer, you could just plug in. So like I could just say, I'm just going to plug in 10. That's something in that zone. I'm going to plug in 1, something between 0 and 9. I'm going to plug in like -1, and I'm going to plug in like -6. That'd be fine. And just test the various regions if you don't want to worry about all that. It's quicker if you remember the bounds pass through in behavior. Just boom, 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 you're done. But it's okay. So, yeah, about even power, odd power. Yeah, basically these are all 1 power. So they're all passers through. Pass through. None of them are bounce. Remember, bounce is if you have an even power, right? That's why x squared bounces at 0, whereas x cubed passes through. Because these are odd powers you pass through because your sign changes, right? Odd powers, the sign changes from negative to positive. Whereas even power, it's positive everywhere. It bounces back up to positive, doesn't it? That's what it's all about. It's about the power on the term. So if you remember that, then you go, oh, it's just going to pass through each of those points. But anyway, if you don't, you can just plug in. You can get there. It just takes a little more work. What am I going to plug into? This. X plus 5, x minus 9. Plug in. Plug in 10, 10, 10. So 10 times 15 times 1. What is that? Positive 150. So it's positive. Now let's go plug in 1 into x plus 5, x minus 9, plug in 1 times 6 times 8. It's negative, isn't it? Positive times negative. So this one's negative. What does that mean? That means the graph goes down here. The graph is up here. It's positive. Let's try the third one. Plug in -1. So into x plus 5, x minus 9. So -1 times 4 times -10. 2 negatives? Positive. So the graph is up here. It's positive. Which we could know because it passes through those dots. It doesn't bounce, huh? Finally, let's check the left side. And this is going to be -6 into x plus 5, x minus 9. Plug in -6. We'll get -6, -1, -15. 3 negatives, negative. Graph's going down. Okay, so now we know a general look of the graph, where it's positive, where it's negative, positive, negative. So what? What's my final answer? What do I want? The positive zones or the negative zones? Greater than 0. Greater than 0 from the beginning, which means positive. They're saying, tell me where that graph's positive. It's positive in here, between -5 and 0. It's positive here from 9 to infinity, isn't it? Do you see that? -5 to 0, 9 to infinity. D. All is well? It's a tough one. We good? Questions on that one? You guys are so quiet. Was that an overwhelming problem or is it an easy one? We're all good?
No.
Good.
Graphs are like the ones that are kind of confusing.
Graphs?
Direction of the graph.
Oh, shifting. Want to do some of those? Yeah, those have been 2 of the major themes of the course, is to make you more comfortable at graphing and more comfortable with word problems. I hope some of that's happening. All right, let's try that one. Which one of those is right? I want to plug in some points to make sure. Remember how you can always plug in points? And that's a good way to double check. Know what I mean? Am I making any sense?